Alright, let's look at the homework 3.3, problem number 4. Alright, so let's take the derivative. So we take the first derivative using the product rule. Right, so we have this is our first guy, this is our second guy. Right, so if you take the derivative of the first guy, you get 1 times the second guy is quantity x minus 6 cubed plus first guy times the derivative of the second guy is 3 quantity x minus 6 squared, and then multiply by derivative inside, which is 1 anyway, so I'm not going to write anything down. All right, before we take another derivative, I'm going to simplify. All right, so you have x minus 6 squared, and we have 3 of those, so I'm going to just circle that so to indicate that there's another x minus 6 there. So we have x minus 6 squared, that's pulled out. Then we have another x minus 6 there. So I'm going to put x minus 6. Right, then we have here plus 3x. So I'm going to add 3x there. Right, so here I'm going to have 4x minus 6. Alright, so I'm going to pull, let's see, 2 is in common, right? 4 and 6. So pull 2 out. Then you have x minus 6 squared. And you have a 2x minus 3. Alright, so that's our first derivative. Alright, let's take another derivative. Alright, f double prime of x. Right, so 2 is a constant, so I'll leave this guy alone. Right, then we're going to take the derivative using the product rule again. So this is our first guy. This is our second guy. Right, derivative of the first guy is 2 times quantity x minus 6 and subtract 1 from the power, which is 1, multiplied by derivative inside, which is 1. Right, and then multiply by the second guy, so it's a 2x minus 3. All right, plus. All right, first guy is x minus 6 squared, and then derivative of the second guy, just 2. All right, so let's simplify. All right, so we got a common factor, 2 and 2 there. So pull it out, then 2 was already there, so that becomes 4. And then you have x minus 6 here. There are 2 of those here, so we can pull that out. So we'll have x minus 6. And what's left over is 2x minus 3. So that came from here. Then we have another x minus 6. So plus x minus 6. All right, so this is going to be, let's see, if you combine that, this is going to be a 3x minus 9. So we can pull 3 out, combine with 4, so that's 12. X minus 6. And then you have 3 is factored out, so you have x minus 3. All right, so if you set that equal to 0, we can see that we get, let's see, x equals 6 and x equals 3. All right, so we're going to do the number line. So draw a number line here. And I'm going to put a couple tick marks, and one for 3 and one for 6. All right, then we're going to look at the sign of f double prime. So anything smaller than 3, so I'm going to try 0. All right, so if you plug in 0 into the second derivative, so that's 12 is positive, negative 6 times negative 3, so that's positive. you get positive, right? And if you try anything between 3 and 6, so I'm going to try 4. If you plug in 4, so positive, so this is negative, this is positive. So positive times negative times positive is negative. Right? So we can try anything larger than 6, which is 7. So if you plug in 7, that's positive, everyone's positive. So we have that. Right, so we know that, original function f is going to be, right, here's the second derivative positive, concave upward, and the second derivative negative, concave downward, and the second derivative positive, concave upward. Right, so let's see if we can answer these questions. Right, so we have from infinity to negative infinity to 3, and also 3 to 6, right? And 6 to infinity. And the sign of, let's see, so which one did we do? So first, positive, negative, positive, right? So we have a positive, so greater than 0. And here, less than 0. And it's greater than 0. So conclusion is concave upward, here concave downward, and here concave upward. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.